Hello, all. Good morning. My name is PraveenKarthik. Today, I've taken a dataset with respect to the insurance claim analysis, demographics, and health from Kaggle, and I'm going to do a clustering model out of this dataset to understand how the data is clustered between various features. So So the problem statement is we aim to identify patterns in the insurance claims data across different age groups. So we are going to identify what age of people are getting a claim of, what range of claim amount. So that is the problem statement, and I've used two clustering techniques. One is KMeans and other one is DBSCAN, and I have tried to measure the accuracy using the silhouette score. So as uh, as a ritual, I have done the collection method. The data collection method is done from the data is from Kaggle, and this is the URL for that, and it has 1340 records. And the key features that involve is region, claim, ages, diabetic, and smoker. And I've done a feature engineering as part of the EDA, and then I've done a data pre-processing. What I've done is a lot of categorical values have been converted into numerical values using the label encoder, and then I've filled in the NaN or the null values with the mean value of the respective features, and then I visualized the data using scatter plots. So So coming to the k-means clustering, first what I've done is I've done the analysis to find the optimal k value. So for that, I've used the elbow curve technique, and then I've done the scatter plotting of the data, and then I've identified the results yielded two clusters. And then I've done and I've also measured the silhouette score for this k-means, and similarly I've done for the DBSCAN, and I've taken a different approach to understand the optimal value for the epsilon and the n samples, and the result that I could infer was that the DBSCAN was not the right clustering model for this data set, and I'll show you why, and that is based on the silhouette score. So the key finding conclusion is that most of the claims were around $15,000 across all the age groups. So that was the inference that I was able to arrive at. So let me jump onto the Jupyter. So as you know, this is my data that I have got it from Kaggle. So it has the different features. And if you see the gender, diabetic, smoker, region, all these are in categorical values, and I have converted that into numerical values using the label encoder. So I've done the shape of that, and I've taken a description of this, and I have identified whether all the data types are data types for the different features, and then I have taken a isNA.sum, which means it will tell you how many values are null for each and every feature, and checked for the duplicacy of records. Then I have filled the null values using mean, and then I've tried to understand how many unique regions are present. So we have 4 unique regions here, and then if you see, I've used a label encoder to convert the categorical values of gender into the numerical values. Similarly, I've done for the regions as well, and then I've done for the diabetic feature, the smoker feature as well, and then here is the and then I've appended the numerical values and dropped off the categorical values for gender, region, diabetic, and smoker. And this is the new data frame, the pre-processed data frame that we are going to apply the clustering model upon. So coming to the model development, so k-means clustering, what I've done is I've taken a range of 10 and tried to identify the optimal k value by taking the inertia of it. And if you see, this is the elbow curve technique, and so there is a sharp turn at point 2 and k value 3. So we have to see which one yields the better silhouette score when we fit the model, when we fit the data frame into this k-means clustering model. And if you see, I have used a k-means plus plus, which means the centroids will be placed very far away from one another across the data set, so that the probability of accuracy is more. And so I have fit and predicted the cluster. So what I've done is I've out of the data frame, I've taken the age versus claim as another cluster, and I mean another data frame, and tried to map the values between them. And if you see this, uh, if you see this, I have plotted the age versus claim, and there are two clusters formed. If you see, the silhouette score is for this two cluster is 0.73. If you see, if I raise the number of clusters equal to 3, the silhouette score is 0.60, which is much lesser than the previous one. So 2 is the ideal silhouette, number of clusters, the K value that we can take from the elbow curve. And this is the graph that is plotted. I could be age versus claim. And if you could see the blue ones, there are a lot of density. I mean, the data is populated between the range $10,000 to $20,000, and on average, if you see, a lot of claims have been made less than 15,000 K. I mean, less than $15,000, and this is the inference that we can arrive at. And I've tried the DB clustering as well, just to be sure about the scattering. So I've taken the same age and claim, and I've tried a range of 1 to 100 for the epsilon value, and also the minimum sample range 1 to 100. So which means there will be two loops running as a nested loop. And I've also arrived at the silhouette score, and I've uploaded the silhouette score here. And to find the top silhouette score, and this is the data frame that I've created, which gives a mapping between the epsilon n samples and the silhouette score. And let me show you how it is in data frame. So I've taken the n largest 50 silhouette scores out of the range 1 to 100 for n sample, and as well as the epsilon, to identify whichever combination gives the best silhouette score. See, even if this is the topmost silhouette score, I can get for a range of 100 for epsilon and n sample, and I don't think this data set is suited for to be clustered using DBSCAN. So I prefer K-means clustering, and the silhouette score for this DBSCAN is just 0.48, and when it compared to K-means, it is 0.70, which is much more accurate than the DBSCAN. So even though this is the plot, even though the silhouette score is less, I have plotted it in the scatter plot. If you can see, the DBSCAN is basically density-based clustering model, and it should ideally isolate the noises automatically very efficiently. But again, this DBSCAN is not really ideal for this particular data set, of course. So that is the reason why I have made a comparison between the K-means and the DBSCAN clustering algorithms here. And this is the final data frame that I've arrived at. So please feel to post your review comments on my work, and thank you.